We've all heard the name Archimedes, and for most of us, it probably conjures up one image: a guy in a bathtub, a splash of water, and a single shouted word. But that one moment, as legendary as it is, it's really just the opening act in the story of one of the most brilliant minds in all of human history. The real story? Well, it's so much bigger. So this is the man himself, Archimedes of Syracuse. We're talking over 2,000 years ago, living in Sicily, and he was the definition of a polymath, a mathematician, a physicist, an engineer, you name it. And this image, it really captures that feeling, doesn't it? A mind just constantly at work, seeing the world not just as a place, but as a giant puzzle of levers, numbers, and hidden rules just waiting to be figured out. But it's funny, right? For all the groundbreaking work he did, for all the complex mathematics and engineering, his entire legacy seems to be tied to this one explosive moment of insight. So, how on earth did one word come to define a man like this? Eureka! I have found it. It's this cry of pure discovery that has literally echoed through the centuries. And it all kicks off with a classic problem: fit for a king. All right, so let's get into this legendary story, because it is so much more than just a tale of a guy running naked through the streets. It's actually a perfect window into his brilliant problem-solving mind. So the setup, it's like something out of a detective story. King Hero II, who is actually Archimedes' cousin, he commissions this gorgeous golden wreath for a temple. He gives the goldsmith a very specific weight of pure gold. But when he gets the finished wreath back, something feels off. He gets this nagging suspicion that the smith ripped him off, stole some of the gold, and mixed in cheaper silver. But here's the catch. How do you prove it without melting down this beautiful work of art? Well, you turn to the smartest guy you know, Archimedes. And the answer, as the story goes, comes to him in the most ordinary of places, the bath. He's getting in and he sees the water level rise. And then it hits him, that aha moment. He realizes that the amount of water that gets pushed aside, the displaced volume, is exactly equal to the volume of his body that's under the water. And that, right there, that simple observation was the key. This is where the solution is just so clever. See, gold is incredibly dense. Silver, not so much. That means if you have two objects that weigh the same, but one is pure gold and the other is a gold-silver mix, the mixed one is always going to take up more space. It'll have a larger volume. So Archimedes took a lump of pure gold that weighed the exact same as the wreath, dunked it in water, and measured how much the water rose. Then he did the same thing with the king's wreath. And guess what? It displaced more water. The fraud was exposed. Eureka! But here's the thing. Archimedes wasn't just some abstract thinker lost in his thoughts. He was a builder, a hands-on engineer who used his knowledge to create incredible things for his home city of Syracuse. This might just be his most famous quote. And it sounds like a wild boast, right? But it's not arrogance. It's a statement about his complete mastery of physics, specifically the principle of the lever. He understood on a deep, fundamental level that with a long enough lever and the right pivot point, a tiny amount of force could move something unimaginably massive. And he put that knowledge to absolutely terrifying use. When the Romans came to lay siege to Syracuse, Archimedes became the city's one-man defense department. He designed super-powered catapults. He built massive cranes that could just drop crushing weights onto Roman ships. But the most feared of all was something they called the Claw of Archimedes. Just imagine this, a giant iron grackle that could reach out from the city walls, grab the front of a warship, hoist it clean out of the water, and then just let go. The psychological terror must have been insane. Now this brings us to another wild story, the legend of the heat ray or the burning mirrors. The tale goes that he used an array of polished shields to focus sunlight into a single beam, setting the Roman fleet on fire from a distance. It's an incredible image, but it's important to know that the earliest, most reliable histories of the siege, they don't mention it at all. This story only pops up centuries later, so while it's an amazing idea, it's almost certainly a bit of legendary embellishment. As impressive as all those war machines were, you could argue that his real genius, the work that would have the most profound and lasting impact, was in mathematics. He developed this incredible technique called the method of exhaustion. Think about it. How do you find the exact area of a weird, curved shape like a circle? Well, he'd start by fitting a simple polygon, like a triangle or a square, inside it. He could calculate the area of that polygon easily. Then he'd double the number of sides, and then double it again and again. With each step, the polygon exhausts more of the space inside the circle, getting closer and closer to the true area. This idea of approaching a limit through an infinite series of steps, that is the absolute foundational concept of integral calculus. It's just that he was doing it almost 2,000 years before calculus was officially invented. And he used this exact method to tackle one of the greatest mathematical challenges, calculating pi. But he was even cleverer about it. He didn't just put a polygon inside the circle, he drew another one around the outside. This essentially created a trap. He knew, for a fact, that the true value of pi had to be hiding somewhere between the value he got from the inner polygon and the one from the outer polygon. And by meticulously, painstakingly calculating this for polygons with up to 96 sides, all without modern computers, mind you, he squeezed the value of pi into this incredibly tight window. He proved that it was less than 3 1/7, but more than 3 10/71. If you punch that into a calculator, you get a value of about 3.14. It was by far the most accurate calculation the world had ever seen. Yet, for all of these incredible accomplishments, Archimedes himself had a personal favorite. There was one discovery he made that he considered so perfectly beautiful, he actually asked for it to be carved on his tombstone. It was all about the simple relationship between a sphere and the smallest cylinder that could possibly contain it. And this just shows you the kind of elegance he found in the world of numbers. The proof is really complex, but the answer it gives is just stunningly simple. A sphere has precisely 2/3 the volume and 2/3 the surface area of the cylinder that it fits perfectly inside. For Archimedes, this simple, beautiful ratio was the pinnacle of mathematical perfection. His life, though, didn't end with a quiet moment of mathematical beauty. His story concludes right in the middle of the chaos of the very war he had fought so brilliantly to hold off, which led to a legacy that was almost completely lost to time. When the Romans finally broke through the defenses of Syracuse, the story goes that a soldier found Archimedes completely absorbed in a math problem he was drawing in the sand. When the soldier ordered him to get up and come with him, Archimedes supposedly just waved him off and said, "Do not disturb my circles." The soldier, enraged, killed him right there on the spot, even though the Roman general had given specific orders to capture him alive. His death was a massive tragedy. And his memory faded surprisingly quickly. More than 100 years later, the famous Roman orator Cicero was visiting Syracuse, and he asked the locals to show him the great man's tomb. Nobody knew where it was. Cicero had to go searching for it himself, and finally found it, totally overgrown and forgotten. The only way he could identify it was by that little carving of a sphere and a cylinder that Archimedes had requested. So if he was basically forgotten, how do we know so much about him? Well, his ideas went on this incredible, centuries-long journey. They were saved and compiled in Constantinople, later translated into Arabic during the Islamic Golden Age, and then finally into Latin, where they helped spark the scientific Renaissance. And then, and this is amazing, in 1906, a researcher discovered an old prayer book. It was a palimpsest, meaning the original writing on the parchment had been scraped off so it could be reused. And hidden underneath the prayers, they found lost treatises by Archimedes himself, including one called The Method, where he explained his secret thought processes. So why does this all matter today? Because his discoveries about levers, about buoyancy, about gravity, they became the absolute bedrock of physics and engineering. His mathematical techniques, as we saw, literally anticipated calculus by 2 millennia. His legacy is so important, so revered, that his face is on the Fields Medal, which is basically the Nobel Prize for mathematics. And that kind of leaves us with a final thought, doesn't it? Archimedes had no computers, no fancy calculators, not even our modern system for writing numbers. He had his mind, maybe a stick and some sand. And if he could get that close to figuring out the fundamental rules of the universe with so little, it really makes you wonder. With everything we have at our fingertips today, what are we truly capable of? Are there any limits at all?